So we're starting to gather here. I think we're about ready. Welcome back, everybody. It's my pleasure to introduce to you Professor Adam Frank from the University of Rochester. Adam does all kinds of interesting things. He is an astrophysicist who works on, well, let's just say he's in touch with aliens, kind of. He also flies through space. This I've seen happen. It's in video games. So yeah, no one else can appreciate that, but we can.
We can. John's my wingman.
Yes.
Or I'm his wingman.
I'm looking forward to hearing what Adam has to say. And actually today I will be responding to Adam. And then we'll hopefully have a few moments for a more general conversation and break for lunch. All right, take it away, Adam.
Well, first I have to say thank you once again for the invitation to come here. The Varela Symposium has been incredibly important for my own work. And my links to it, as we were talking about earlier, go all the way back to reading a book when in my 20s by William Irwin Thompson, who was the founder of the Lindisfarne Society or Foundation. And it's through that strange reading his material, learning about him, that I came to know Evan Thompson, and that Evan suggested that I come here, and it has utterly transformed my thinking about things. So today what I want to tell you about is work that's actually come out of the 5 years of being involved in this, and it's towards the physics of life, semantic information. So I always start off, some of these slides, if you've seen me talk here before, are going to be from earlier talks, and that's on purpose because things are developing. But I always start off with the harmony of the relative and the absolute, or the Sandokai. And this is a poem from 8th century, but very much part of the Zen tradition. And it's very important to me because what I'm very interested in as a physicist and a practitioner is this idea of the harmony of the relative and the absolute. So let me just read it. Each thing has its own intrinsic value and is related to everything else in function and position. Ordinary life fits the absolute as a box and its lid. The absolute works together with the relative, like two arrows meeting in midair. And the first time I heard this when I started practicing, I found it enormously powerful. And one of the reasons I found it so powerful was its relationship to what I'd learned in science, right? So I often always start with this. This is a book, a real book, called Science and Ultimate Reality, right? And it just cracks me up that there's a book with this title, right? Because as a physicist, as a young physicist, this is what I wanted. I wanted a gaze into ultimate reality. It sounds like, a superhero movie or something. And this is science's version of the absolute, that science is going to give you a view to something that is timeless, eternal, has nothing to do with human beings or their human view. That's what makes it so attractive. So, I was entranced with this idea as a young man, as a 17-year-old, I also thought that maybe if I knew something about ultimate reality, more girls would talk to me. And it turns out that was not true at all. I thought like motorcycles, rock and roll, and ultimate reality, but that didn't work out. Oh well. So the idea here from the physics point of view is that there is an ultimate, fundamental, or basal structure, a basal reality, and it's the job of physics to find it. And really what we're talking about here from the physics, the classical physics view, I mean classical, what I mean is the view that we get as students of physics, the dominant view, is that what we're interested in is the world without us. We're trying to read God's thoughts, basically, and that's what makes it so seductive. Now, we've been talking about changing narratives and the importance of changing narratives around science. We're in the midst of this polycrisis, which science has both helped drive, science and technology, and then the philosophies that sort of got embodied in, in economics, that we require new narratives about the world and our place in it. But we can't ignore physics in this. We can't what we've talked about so far have been things that are kind of higher up the organizational chain, things like, cognitive science, cognitive science. But you can't ignore trying to bring these new perspectives to physics as well. And that one reason, there's a lot of reasons, but one is it's the role model for, we talk about Homo economicus. And what happened with Adam Smith and those guys is they were all looking at Newtonian physics. And that was like the model, like, yes, we need to understand the world in that way. And so they what they were hoping for was a theory of economics that would look like physics. Another reason is that, well, or not the reason, but the challenge here is like, where in physics do we find inactive view or embodiment? And you can't do this. You can't try and like refigure the relationship between the subject and object in physics via what's called social constructivism, which sort of says, oh, physics is just, it's a game. It's a game that the powerful play, because physics is too powerful. Physics is, it works so well. And what I mean by that is you have to account for how profound the effectiveness of mathematical abstraction is in physics. And so when I was up at the, what I mean by this, when I was up at the retreat, there's a little picture of looking out from the cave. I was reading this book there was something I was interested in about classical field theory, a particular piece of mathematics, which is this called the Lagrangian for electromagnetism. And it's basically anything that happens in electromagnetism, electric fields and magnetic fields, is right in there. It's already in there. So the workings of this all come down to the power of that abstraction. And so you can't ignore it. You can't pass it off. You can't sort of wave it away and say, oh, well, it's just human beings doing this. You have to work harder to understand that. And so I want to talk about a way of doing this maybe that is asking a different question in physics. We usually think of physics as being about space and time and particles. But now things have changed in our abilities to do science, that we can ask a question about life, about the physics of life. And this goes actually back to a book that Erwin Schrödinger wrote in 1944 called What is Life? It was a physicist's view, and it was absolutely important. And one thing he was beginning to ask was, does life require new physics? Life is different. And does it require us to change the laws of physics, or can we account for it with the laws of physics that we have? And what the question about this is like, why, you might ask, why? Why does life might require new physics or new perspectives? And the importance here is that life is unlike any other physical systems, right? We know that, the physical universe makes mountains. There's a nice mountain, comets. There's a beautiful image of a comet up close. It makes stars. But these things are very different from the other thing that can happen in the universe, and that's like kangaroos, right? Because here's a kangaroo. Kangaroos are weird, right? They're like giant rabbits that can punch you in the face. And how did you get a kangaroo? A star is not going to make a kangaroo, right? And so the important thing here is that life, unlike any other physical system, life innovates, life creates. And so what I mean by that is, if you give me a star and you tell me its current state, meaning the location of every atom in its, inside of it, I can pretty much predict the entire future history. And here's like a life cycle of a star going from a cloud that collapses, and then it becomes a main sequence star, and then it bloats up and it dies. The star's not going to surprise me. I know it's amazing. The physics is amazing, but it's not going to surprise me. You give me a cell and give me its current state, I am not going to be able to tell over the long term what's going to happen in terms of the evolution from that cell, right? And we know that, right? So here's this route from, single-celled critters up to us. And if I went back and replayed the tape, I probably would get a completely different story. Whereas if I went back and replayed the tape here on the star's evolution, I'd get the same star, maybe some small changes. So life is unlike any other kind of physical system. Now, there's a way that physics has been involved with the study of life that is what we call, my collaborators and I call the blind spot narrative. There's this view that gets associated with science that we call the blind spot, which, sort of, again, it's this very reductionist view. It's a view that is really has a hard time understanding life. And what it does with life is it uses what it calls the machine metaphor, that life is basically a biochemical machine. It's a computer set by programming by your selfish genes, and you are basically just a meat computer with a gooey robot body, right? And that's the account that you're going to get out of sort of the mainstream view that gets glued onto physics. So it's this kind of thing. It's just, a fish is just a fishy machine, and there's nothing else going on. But the interesting thing about the machine metaphor, and there's this great philosophical writing, and in working with Evan and Marcelo Gleiser on this book, The Blind Spot, I got to go into this in much greater detail, is that the machine metaphor fails in all kinds of important ways. And this is this general idea of what we call the blind spot, this reductionist view of science that, oh, if you know about the atoms, or the quarks, if you know everything about the quarks, you're done. You can predict the entire history of the universe. It fails in so many ways. It leads to so many paradoxes that you then have to do all this intellectual yoga to get yourself out of. And then what you're left with is stuff that doesn't make any sense, like multiple universes or string theory or things. But for biology, the machine metaphor fails in a very simple way, right? You can turn a machine off. I can, turn this off, but I can also turn it back on, right? You can't do that with life. That is like, yeah, you can maybe hibernate life, but you can't turn it off. Right. So this is this beautiful image. Actually, there's this YouTube channel I love to watch, which they call it the microcosmos. And it's all just single cell to the lives of single cell critters. And what you see here is this is a cell that has undergone, I think it's lycosis. Is that what it is? Biologist. Where basically the cell wall has broken. And, here it's alive. It's flitting around, moving all of its little parts. There's all kinds of amazing biochemicals reactions that are going on. And then it died. It just stopped. And then everything just diffused away. So life, precariousness, is essential to life. It's an essential definition. It's really hard to talk about the precariousness of a rock. The rock will erode over time, but it doesn't have this kind of, this particular kind of configuration that lives in a precarious state. And along with precarious, as we're going to see, there's this very important idea of viability. So health, if you want to call it well-being. So what is it that makes life different, right? We've talked about, the idea of life's innovative and creative possibilities. What it turns out is that information may be the thing. There's a bunch of thinkers who sort of will go down this road. It's information that makes life really different. Life is the only physical system that collects, stores, and processes information. Right? It's one thing to just talk about information existing, but life is the physical system that uses information. So, here, for example, is a network of proteins, and there's all kinds of information in that protein network, as well as the information about the environment that a cell will be able to, detect, process, and decide which of those proteins to churn out, right? Or which of those proteins to use. And this is not just like programmed into the genes, right? Because as we all know, genes, it depends on what's happening in the environment, which genes are going to be activated. So it's far more complex than the selfish gene idea, which was, so reductionist and it absolutely does not capture what's going on. Now contrast this with a star. Stars have networks. This is right there is the stellar reaction network of how a star will take hydrogen and then build up heavier elements, the heavier elements that make you up. It's information rich. There's a lot of information in there, but the star doesn't know about the information. The star doesn't use the information. It's, I know there's information because that's the way I view the world, but there's no agency. Now there's the appearance of that very important word of agency. There's no agency going on that uses the information, responds to it, changes its behavior based on the information. So information is key for life. And that may be the real pointer to coming up with a different way of thinking about the physics of life, and therefore also coming up with a different way of thinking about, the subject and object, the way how to think about physics and have a subject back in the description that physics has of the world. And so along with that comes this question of what is information? And so I have a good friend of mine who's a quantum mechanical theorist named Andrew Jordan, and he says jokingly, half jokingly, information is the spiritual quantity of physics. Because it's hard to say like, well, where is information? It's kind of like floaty around, like, I can pick up a rock and hit you in the head with it, but I can't hit you in the head with information. So this has been a debate within physics, and so the question is information physical, right? Because of course, the dominant philosophy that gets glued onto physics is that of physicalism. The whole world is physical. There's nothing else other than the physical. And anything which can't be described as physical doesn't exist. And it does turn out that, yes, information is physical. There's something called the Landauer principle, which is really beautiful, which you can show that, there's a certain energy cost to erasing information. And that energy cost is what sort of shows you that, physical information is physically instantiated. But we can think about different kinds of information. So this definition of information has this this Landauer principle associated with it. But now what we have to do is we have to sort of think about how we think about information and how we what we mean when we talk about information in living systems in particular. And so I want to talk now, I want to introduce you to the difference between syntactic information and semantic information. So syntactic information is the stuff that all of this technology is built on. All of these beautiful, amazing machines come from a paper from 1948 that Claude Shannon, brilliant paper, wrote. He was the founder of information theory. And what Shannon was interested in was how information, how a message gets sent through a communication channel. Right? So here's Claude Shannon. This is the diagram in the paper. There's the information source, and it has to go through a channel. And there's noise. How much of the message gets through? And so what he meant by this, as he designed his mathematical formalism for this, for him, syntactic information, that's why we're going to see why we call it syntactic. Information for him was syntactic, meaning that it was all about the surprise. You had a string of characters, and the question was, the next character that came along, were you going to be surprised or not? So message one, here's one message, which is this long string of zeros, right? And the difference between message one and message two, which is the same long string of zeros, but with a one in it, there's some surprise in there, right? You would expect with this message one that, yeah, it's just going to be zeros forever. Like you can go to sleep, it's going to be the same thing. But message two, it's like, oh, something happened. Like a different character appeared. So what we call Shannon information is based on the syntax, just the characters and how the characters appear. I've got an alphabet, I've got a bunch of possible characters, and they can appear in possible sequences. And I'm interested in how many times this character or that character appears. So you begin with a message, which is a string of characters, and you can define something called the Shannon entropy, which is a measure of the surprise in the message. Conversely, it's also a measure of redundancy. This is where compression algorithms, how they work. So look here, this is a sentence. This is not a sentence. This is not a sentence. You can see I can add all these E's, but it's not really going to change anything, right? I'm not changing the surprise, and you can still read it even though there's all these extra E's. So again, it's really all about it's about syntax. It's just about characters and their appearance in a string. Now, here's the amazing thing about all these technologies, everything which has been transformed by information theory. Here's a quote from the paper. Frequently, the messages have meaning. That is, they refer to or are correlated according to some system with certain physical or conceptual entities. These semantic aspects of communication are irrelevant to the engineering problem. So, holy crap, right? The entire information theoretic engineering structure we've built has no meaning in it. Meaning was deliberate, and it was a brilliant move because that's what Shannon needed to do to be able to build the kinds of things he needed. You squeezed meaning out. He was explicit. It has nothing to do with meaning. And yet, semantic information that has meaning, that's what life uses. That's what's essential to life. For living systems, information always has valiance. It always has import. It always has it always means something. Duh, right? And so this goes to Gregory Bateson's very different definition and Bateson, who was very much part of the Lindisfarne movement, real important player. Information is the difference that makes the difference. That's not in syntactic information. Syntactic information, it's like, oh, there's a one. Oh, I'm surprised. Who cares? Next, right? It's the difference that makes a difference. But makes a difference to who or whom, right? There's always a knower and a known, right? There's an agent, right? And that is going to be super important to us. Okay, so that's my kind of introduction stuff. And now I'd like to say, kids, fun time's over, because the next part of this, and hopefully it'll, won't take more than. Okay, yes. Well, that's going to be particularly important to slow down for what we're next going to do. So I'm going to show you the attempt that my group is part of to develop a theory of semantic information. It wasn't easy, but Shannon developed a theory of syntactic information. It was potent. There's never been a theory of semantic information. I mean a theory, a mathematical physics theory. Just like, I showed you that mathematical thing called the Lagrangian for electromagnetism. We need a applicable theory of semantic information that is going to be based in the physics, what we call statistical mechanics, and information theory. So I'm going to try and show you how this works. Sorry, let's loosen up a little bit. All right. The question we're going to ask that we want to focus on is, what is an agent? What is an agent, and how does an agent arise? Very fundamental problem, right? Because this is related to what is life. Now, the interesting thing about agents is that agents always show up with environments. So here are 4 examples of complex systems, systems that are not in equilibrium, they're constantly changing, they're made of many parts. And so here's a hurricane in an atmosphere, here's a cell and its milieu, here's an ecosystem, and up here is a city. Now, the interesting thing about this is that, okay, the cell is clearly an agent. The cell's going to respond to the environment. Do we want to call an ecosystem an agent? Maybe, right? I mean, it responds to the surroundings and interacts with its environment. And cities, that's at a very high level, but cities, we might be able to consider cities as an agent as well. But hurricanes, hurricanes are dynamic. They respond to changing temperature conditions. They'll move depending on the environments, but we wouldn't want to, we don't want to consider, we don't think we should consider a hurricane an agent. So actually by considering all 4 of these, maybe we might, if we had a theory of semantic information, and we want to ask this question about how agents are, what are agents and how do they arise? Well, maybe it's through the emergence of semantic information. Maybe it's the emergence of the thing that separates the hurricane from the cell is somehow between these 2 complex dynamic systems. One of them, semantic information, has emerged and started to be used, right? Because the syntactic information, that's not really the important thing for life. It's the semantic information. So that's the hope. That's where we want to go. So what we need, So the question is, can there be a theory of semantic information, SIT, semantic information theory? And the answer is maybe, right? So this is this beautiful paper that that Artemy Kolchinsky and David Wolpert wrote a little while ago, 2018, and it's from they're at the Santa Fe Institution, or Santa Fe Institute, excuse me. Semantic information, autonomous agency, and non-equilibrium statistical physics. So you see, this is a physics paper. It's a physics problem. And I'm going to tell you now the basic idea. So how they tried to formulate this, because what's happened is that I contacted Artemy, we started talking, and now we have a grant, as I'm going to show you. We have this from the Templeton Foundation. We have a program that we're working on to try and take what they did in that paper and start applying it and start learning from it. So their basic idea is really cool. You start off with a system. You consider the system to be an agent, we'll call it A, and the environment E. And then what we're going to do is we're going to define a measure, we're going to have to come up with it, of the agent's viability, V. It's health, it's well-being, right? So you define that, okay, you've got that figured out. And now what you do is you watch how the agent and the environment evolve together. And then at the end of some time, you watch your little clock and you're like, oh, okay, you measure the agent's viability. We'll call it V sub 0. And now what you do, you turn the clock back. You imagine you could, right? You can do this in simulations, or you can do this in experiments in certain conditions. And you scramble some of the information between the environment and the agent. And I'll talk in a minute about what I mean by that. You mess up the relationships between the agent and the environment. And then you run it again. You run the whole experiment again. You rerun the evolution, and you measure the new viability of the agent in this, we call it the intervened evolution, because we've intervened at the beginning and messed up the information. Now, is the agent more or less viable in this new case where we scrambled the information? Is V1 less than V0? And if it is, what that means is some of the information that you messed with was semantic. Some of that information that you rearranged, pulled the wires out, that was information that was necessary for the agent to survive, to be viable. And so it's a very simple idea, but enacting it mathematically and from a physics perspective is very difficult. Now let me give you a real world example if that was too abstract. We're going to think about squirrel in a forest, right? So you have an agent, which is your squirrel, and you have an environment, which is a forest, right? And the squirrel has hidden nuts in the forest, right? And so the information that we can scramble between the squirrel and the forest is the location of things like the bushes, the trees, the rocks. We can change the winds, the heat, the humidity, et cetera, because we don't know which of these pieces of information are important to the squirrel. The squirrel has to find the nuts, but maybe the squirrel hid the nuts based on, the certain kinds of bushes. Maybe the temperature doesn't matter at all. Maybe it does matter, right? We don't know this until we do this. Somehow we have to figure out which is the information that matters to this agent. And so here's a little diagram of what you do. Here's our little squirrel who's like, no, don't make me do this. And the blue line is the first case. Like, this is the case where we haven't intervened. So moves along, moves through the forest, finding or not finding nuts. And then we can track its viability, its health over time. So this is the blue line here. And now, so this was the first case, and it found its nuts, and there it's very happy, right? But in the second case, we screwed up the information at the beginning. We mixed things up. And now, in this case, the agent didn't know where the nuts were anymore. And, the viability changed over time and it died, right? And so the difference here, somewhere in the difference here, we are going to be able to find the information that was semantic, the information that was meaningful to the agent. And that's what makes this so potent, right? We have a way of identifying which parts of this collective, the system, the system is the agent and the environment, which parts actually carried meaning with them. Now, you'll notice what's interesting about this is that this word viability came into it, right? That we have to define a viability, because viability and precariousness are they're the two sides of the same coin, right? And so what's beautiful about this is that it introduces in a natural way both meaning, right, which is this thing, it introduces information, the kind of information that is necessary for life as opposed to the syntactic information. And along with it immediately comes the idea of precariousness, okay? So viability and precariousness are basically the same thing. And so what it introduces is that, when people talk about the enactive embodied approach, right? Francisco Varela said what we're meaning there, if I get it correctly, is that, that approach, the embodied enacted approach, is sense-making in precarious conditions. Life is sense-making in precarious situations. That's what semantic information is. We've been able to identify explicitly and have a mathematical account of what that means. It's the semantic information. Now, so what we're trying to work on now is to develop this semantic information theory. It's just started, right? They wrote the paper. The first paper, even as Artemis says, it was a manifesto, really. It was, it didn't work out. It gave a broad sense of what this theory could look like. And so, it is not an easy read. Here's just one mathematical term in it. And you look at all the little pieces of this, it's like, you got to really stare at this. Even if you're cognizant of, what these terms mean, it's just holding a lot. And it wasn't, they only had kind of one example, one very simple example that they used in the paper, because they were laying, like I said, it was a manifesto. So what we applied in 2022 to the Templeton Foundation for a grant to try and learn how to bring this into the world, like make this applicable. Something you can develop the theory more deeply, and that you can also bring to experiments, right? Study cells in or squirrels or robots. This is applicable to artificial life as well. So the first thing we wanted to do was study things like protocells, food webs, simple systems, applying this formalism and see what we learned, and then go for the really big questions. And what are the really big questions, right? The questions actually that are relevant to what we're trying to do here. And that question, is really, how do the agent and the world co-evolve? How do they appear together? It's not just about the cell appearing on its own. It's about the world that the cell is in, the environment that the cell is in, the possibility that there is co-evolution, co-emergence from them. And as we'll see, this is going to be very different from the kind of idea that physics, the metaphysics that gets glued on to physics, where there's just, it's the God's eye view. There's the universe out there. It's independent of you. The universe is eternal and timeless. This is could be a very different view. And that's what we're trying to go for here, maybe, right? And the reason why this might work, and I really want to focus on this and go slowly through this, is that this mathematical description of semantic information really comes down to an entity, an object in the mathematical theory, something called the mutual information. And what is the mutual information? The mutual information between two things, x and y, and it's written as I of x and y. Why it's not m, I don't know why. It's the extra information you get about X if you know something about Y. So you got these two systems, and you think they're kind of maybe interacting. And if you only knew about X and you wanted to predict the future of X, you only have a certain amount of knowledge. But if you knew Y, you're going to learn something else. So what do I mean by this? Okay, X is Adam, and it's the fall, and you want to say, well, is Adam going to be happy in the fall, right? And so there's all you know something about Adam, but you don't really know. It's you're going to have a hard time determining whether this is true. This is actually me last year in the Adirondacks. So okay, you want to know, is Adam going to be happy in the fall? Now you have information about another system, which is the New York Mets, and that the New York Mets, Adam is a New York Mets fan. And so now, by knowing about the New York Mets, this other system, you know that Adam is not going to be happy in the fall because the New York Mets never win, no matter how much money they spend on new pitchers, right? So by learning about the New York Mets, you've now learned something else about, that's what we call mutual information. There are correlations between these two systems. So here is the mathematical expression for mutual information. And I'm not going to go into it. I just want to show you that, again, just like I showed you the Lagrangian for electromagnetism, there is an expression, a mathematical object that can be manipulated that for the mutual information. And what I want you to understand is the mutual information which is what we mean by semantic information, is all about correlations. It's all about relationships. But that's what that piece of mathematics is getting to. So what I think is it leads to an entirely new way of seeing, as we'll see, not just life, but also life in the world. So, we start with a bunch of things, right? And some of these things, in the world, we go out and we look at the world and we see lots of things. And some of these things we're going to group together and say, oh, that's an agent, right? Yeah, there's a heart, there's a lung, there's some eyeballs, there's some, feet. And there's a bunch of other things we're going to say, like, oh, that's the environment, right? Trees and bushes and rocks. And so, we're kind of grouping the world this way. And now we start to watch them evolve, right? We watch them for a while. And what we see is that there are correlations start being established between these things. So, the eyes in the agent see a rock. The eyes see a bush. The nose picks up some molecules in the air in the forest. The forest actually, gets footprints because of the feet of the agent. Well, I won't belabor this, but you start to establish correlations between what you're calling the agent and what you're calling the environment, right? And so you establish, and this becomes eventually this incredible dense, and really, I'm not even beginning to draw how many there should be, dense network of relationships, right? And what you find from this perspective with semantic information and the development of, looking at it through this perspective of mutual information or correlations that establish well-being, the flip side of which is an expression of precariousness, at some point, what really matters? It's the correlations. It's not the thing you called the agent or in some sense, the agent and the environment, that's not what's real. It's the relationships that are real. From the perspective of the theory, it's the arising of the tying together that makes the agent and makes the environment the environment. And to me, this leads to an entirely different way to think about this, right? So the big maybe here, and it's a very big maybe, to trying to have a view of physics that also includes, sort of the role of the agency, the role of observers and objectivity, is that with this focus on semantic information, maybe it lets you see how the agent and the environment arise together. They are mutual. The correlations, i.e. the relationships, co-create. The agent is the agent because of the world, i.e. the environment, and the world is the world because of the agent. Neither one exists separately, okay? And so this, John brought this up, this idea of chemotaxis, right? So he was describing, when a cell moves up a sugar gradient, right? The cell is like, oh, there's more of the stuff I like up that way. You take the cell out of the picture, and is there even a sugar gradient, right? For whom is there a sugar gradient? There's molecules, right? And but the only way you can talk about the sugar gradient, is you have to sort of project some view, right? We talk about views. You have to project some view of looking down on, like, so that's why you get this kind of God's eye view. Well, there's nobody there, but God's looking at the sugar gradient, right? It's the presence of the cell that the sugar gradient becomes meaningful, becomes a sugar gradient, as opposed to just, there's just atoms everywhere with different densities. So again, it's this idea that the agent is an agent because of the world, and the world is the world because of the agent. So to me, remember I talked about basal structures? The whole purpose of physics was to find the basal structure, the ultimate reality. And what I think may come out of this, and I don't know, this could fail, is a new basal structure. Not the basal structure, but perhaps there are multiple layers of basal structures, or independently existing but correlated basal structures. And that what we really have is a co-arising, what really exists, if you want to say it that way, is a co-arising network of correlations extending through space and time. So this network, imagine this network just expanding, again, both through time and space, because it's dynamic, which is where the precariousness comes from. And when we want to think about the agent and environment, the self and the other, the world, the self and the world, for a temporary period, some part of these correlations emerges as an agent, that's you, and then the rest of the world emerges with its agency. And then after a while, it goes away, right? It's a temporary configuration of correlations. And so, this goes back to the Roshi Jones' famous story with Gregory Bateson and Salk, was it, right? Where Gregory Bateson and Salk were talking to each other at the Lindisfarne Society, and Bateson asked Salk, Salk was kind of a reductionist kind of guy, and Bateson said, "Where's your mind? Where is the mind?" And Salk said, "Up here." The standard, reductionist physicalist answer. And Bateson said, "No, out here," right? And so, from this perspective, where are you? You're everywhere. Mind's agency it's always an ecosystem. Right? You can never sort of just say, it's just up here. You're just an individual agent. Individuals are always embedded in ecosystems of other minds, of other practitioners, of agency. And that includes, because as we've just seen, that includes the environments themselves. So that's a certain sense of, the boundlessness. And it's one of the things I love about the way you guys do the four vows, boundlessness. There's no boundaries, or any boundaries that you have are temporary. Cell membrane, it's just a temporary configuration of correlations. So this goes back to this question of syntactic information. Remember I said syntactic information is physical, and people who want to argue for a kind of reductionist view will say, see, information was physical. There's nothing, nothing fruity-tooty about it. But semantic information is architectural, right? It's about structures. It's about relationships. It still is physical. It's embodied in the physical. Again, there's nothing, metaphysical here. We're not asking for we're not asking for supernatural, God forbid, interactions. But it's this other level. It's this other way of looking at the world. It's architecture, a dynamic architecture of correlations. So just to sort of close up, I want to again sort of contrast this with, I want to bring back to the idea of the relative and the absolute, right? So what's interesting about science, and this, what we call the blind spot, Evan and Marcelo Gleiser and I, is that the relative and the absolute is in the Western perspective, because it very much holds the legacy of the Abrahamic traditions with a monotheistic God who was sort of the reference frame for everything, and the Greek philosophical traditions was that the absolute was the eternal, the objective meaning it exists independent of anything else, always has existed. It's transcendent, it's the ultimately real or ideal, it's the ontic, the purely ontological, the absolute essence. And if from the religious perspective, it was the divine, and most importantly, totally disembodied, right? And so it made it so attractive, It's like, oh, this is the way to get free of the horrors of the world, right? You contemplate the absolute, because the absolute in some sense has nothing to do with the world, or at least it's as the Plato's idea of the cave, it's the relative is the pale reflection of the absolute, right? It's the temporal. So the relative in the Western perspective is the temporal, the subjective, the psychological, the epiphenomena, right? Which means it's not really real. You know, it's like, oh, it's an epiphenomena. Yeah, you know, your consciousness is just an epiphenomena of the machinery in the meat computer. You know, it's the epistemological. It's just about knowledge, you know, and knowledge is not, you know, what really matters is the ontological. That's what really exists. And we can argue about how we have knowledge, you know, epistemologies of the absolute reality. And from the religious perspective, it's the fallen, right? That's a very important thing. It's the fallen, it's the sinful. And most importantly, it's embodied. But you know, what we know from, you know, one of the nice things about the classical philosophies of India and Asia, you know, that were, you know, just like the philosophies in the West got very tied to the Abrahamic tradition. The philosophies, classical philosophies of India and Asia were tied often to Buddhism, was that a very different perspective on the absolute and the relative, right? As I said, the absolute and from what I read, the absolute and the relative fit together like a box and its lid. You can never fall into just the absolute or the consideration of the absolute and the relative. Form is emptiness, emptiness is form, right? So this leads to, and I'm almost done, you can see sort of how the inactive and embodied perspective now can be brought into physics, right? Or at least one aspect of physics. So this idea, one way of expressing it is the participatory universe. And John Wheeler, one of the greatest physicists of the 20th century, you know, drew this diagram, and he was really interested in quantum mechanics. And you'll notice I don't really talk about quantum mechanics. I don't think we need to talk about quantum mechanics to have the participatory universe. But you know, it's this diagram of, you know, the eyeball, you know, the self looking back on the universe. The two, again, participatory, right? They were co-creating. And I think what the semantic information, the perspective of the theory might do is allow us to see how this works without quantum mechanics. Quantum mechanics is still gonna be very important, but it's already happening. Even quantum mechanics is just the sign that this was always happening in a way. So what it means is you can't take us out of the story, right? The view of physics often was you can take yourself out of the story, and that's what they wanted. We wanted to be free of being human, right? And what this says is like, no, the beauty of human life is that we are always part of the universe, right? We are always part, and we are part of the universe's stories. So you remember I talked about like what physics wanted was an account of the world without us, right? And so the response here is like, yeah, of course there's a world without us, right? I mean, we didn't emerge from nothing, but it's not this one, right? I can't say anything about the world without us. That's not the world any of us inhabit. Nobody's ever had an experience of the world without us. And physics and science doesn't give us a view of the world without us. The beauty is it gives us this participatory part. That's the questions now we want to ask about, is the participation. And so that's the harmony of the relative and the absolute, I hope, in science. Mic drop. So I'll just end with this quote. 41 minutes.
Yeah. I'm impressed.
Dang.
I'm going to talk a little faster than Adam.
That's my normal rate, man.
I know.
Jersey.
So there's a lot I could say, actually.
I'm going to hear it sooner or later, I'm sure.
Yeah, I hope so. So fantastic. And I think we're on the same page in many ways, but we're definitely not on the same page in some ways.
Okay.
And so I'm going to go there because I think it's more interesting.
Yeah.
Rather than just saying, oh, we're all on the same page, hooray. Echo chamber.
Yeah.
You know, first thing I would say is just a couple of footnotes. Some of this really reminds me of Varela.
Mm-hmm. It's got pieces, yeah.
Yeah, right. Especially
relational.
The mutual information thing and like action at a distance.
Yeah.
Really sounds like, I mean, Ravelli's thing about how that works sounds like what you're talking about. Mm-hmm. Maybe, okay, maybe not. Other thing is integrated information theory. Tononi, I think. Yep. If you haven't looked at it,
no, I do. I know a little bit of it. Yeah, no, yeah. There's definitely pieces.
So there's some. Just wanted to say, just in case you hadn't. It just. Yeah. I can't tell you the details, but it just seemed like there was some resonance.
Well, it's information theory. They use that similarity is simply that they're using, which shows that this idea of information, how it's coming into physics.
Except I think they're trying to do the same thing. They're trying to bridge the syntactic into the semantic.
I don't know. I mean, I would take some issue with that. It's how you do it, though. See, that's the question.
Yeah.
It's how you do it, and whether or not. This is the other thing, like with integrated information theory, which I think is very interesting. It's really hard to actually ever apply to anything, right? And so what we're trying to develop is.
I'm not going to. I mean, I've been talking to Giulio a lot. I'm not going to even attempt to like defend it, and I don't want to make this a distraction.
Yeah,
so
yeah.
just pretend I didn't say anything about it.
So sorry, what were you saying, Ian?
So one of the things I just want to bring us back to is that, you know, you had like, you can maybe go to that slide, like there was no, don't bother. It's the ideal. So it's like, there's the sort of the blind spot stuff and kind of your American, you know, cultural history is one of the things is the idea that the ultimate is the ideal, right? Like this physical chair is not the real chair. The idea of the chair is the real chair.
If you're an idealist, you don't have to be.
Well, no, if you're Platonic, right?
Right, if you want to take, right.
So that's when you did that thing, like there's the ultimate and the relative, the sort of Western history, and also for some Indian traditions as well, that Buddhism is working against. The real thing is the ideal form, not the physical form.
Right.
Right. That's the ultimate.
Right.
And this is like the impure
It's
reflection.
a crappy version of it.
So another way of talking about that is the model of the chair is the real chair. And the actual chairs that you measure are not the real chairs because models are reality. So I'd like to suggest that one of the things that maybe is an issue for me here is the idea that you're kind of losing track of the idea that the model is just a model and it's not reality.
Okay. I think I do agree that that's always true. That, you know, because models are always, because we have to use language.
So,
right?
But then models are for a purpose and they assume they have certain kinds of assumptions in them. And one of the other main assumptions here that wasn't kind of in that list, in that sort of Euro-American, I don't like the word Western. Because, you know, all of everything below the Rio Grande is in the West, but it's not like necessarily your American culture. And there are a lot of people in North America who aren't from that, you know.
But this is, I think, very much the Western tradition. The Western philosophical tradition.
I just don't like the word. But anyway,
so I will never use it again.
Good for you. So models have, thank you. Models have a purpose. Can you keep doing that? And one way of thinking about what the purpose of this model is to kind of figure out what the heck agents are. Mm-hmm. That's a very Western question, to use your term. So one way of saying about it, one way to think about this is the question of like free will. And so free will emerges in your American historical cultural history as a primarily theological problem, because you've got to figure out, like, if you're going to go to heaven or hell, so if you're going to have a kind of retributive justice approach to justice, you've got to figure out who's to blame. Someone's got to be the one who made the choice. Mm-hmm. And so you see, even in contemporary contexts where there are, you know, there were some well-known cases in Germany a few years ago where people were saying, it's not my fault, my brain made me do it. Right? It's been in the States too. That's right. And I think somewhere in the Southwest, right? I think, yeah. So so the idea here is there's somebody in charge who's the agent, and then the agent like makes choices, and therefore, if they make the wrong choice, they go to hell, and if they make the right choice, they go to heaven. So it's like a retributive thing, right? But it's based upon the choices made by a free agent. Buddhism doesn't have that problem at all. I mean, you can kind of, in my view, bend over backwards a little bit. There's been some Western scholarship, some Euro-American scholarship by people in the academy about free will in Buddhism, but you can't find a text on free will in Buddhism, among classical Buddhist texts, because the whole idea is dependent upon this idea that there's an agent who's like in charge making choices. Okay, so from that standpoint, then the whole question of agency is kind of an illusion for the Buddhists. It's because agency is taking the squirrel and treating the squirrel like it is making choices kind of independent of its environment. And you have an intuition, which is that independence is false. But the Buddhists are saying, like, you're even beginning from the wrong assumption that the agency is the issue. Because if we're just modeling the world, so if physics, my friend Bob McCauley knows Mark Johnson, who gave a talk at Georgia Tech some years ago, and it was about the idea that mathematical objects are actually the products of the way in which human cognition kind of tries to understand what's going on out there, very successfully.
Yeah.
And he said, but they're the product. They don't exist in the world. He didn't know most of the math department was there, and he nearly got thrown out of the third floor window. It's like, no, math is real, right? Not a model, it's reality, right? So that's, I think, part of what is also involved in agency, because if we're agents, then our models of the world are like real. Okay, so one way to think about this, and I think the squirrel in the forest is a very interesting example, because why isn't the forest also an agent? And you kind of pointed that out. If we could consider the agent, but why aren't they together?
They are together.
But what I mean is, why do we put agency? Why does agency have to be even with a star? Like we, from the standpoint of our illusory agency, are modeling the world, and we're going out and choosing this thing's an agent, this thing's not an agent. But that's from our standpoint.
Okay, so
of illusory agency.
But you're asking a different question. You're asking a question that, because what you literally are asking a different question, because the question here is, how does science, how does physics, which is tasked with certain developing accounts of the world and developing mathematical accounts that can be applied to whatever objects we think are the subject of our interactions, or of what we're interested in. And in this case, you want to find philosophical underpinnings that may be useful. But here, the task here, and that has been impossible, I think, from the old view, from the American view, what I would call the Western philosophical view, is to understand how to have the agent, the observer, be part of that description, now it's always good, because it's I have to use words, right, to describe it. To do physics, I have to use words, and I'm using mathematics, which is another form of language. So it's always, it will never corral experience, right? So I'm not expecting that what I'm going to get out of this is going to be the final account, but it's an account that has never existed before. And when you look at ITT, what you're seeing is that what is beginning to emerge is the recognition that there's this thing called information that plays a fundamental role in these things that we encounter in the physical world that physicists are interested in. And it allows a very different perspective on the ability to tell stories about us in the world. That's what I think it's important. I don't think it's ultimate. It's not an ultimate reality.
So let me ask one quick question, and then we'll see if there's a couple others, because we have a little time. A quick question then. And so in the context of chemotaxis, the organism has a model, right? From its standpoint, like it's got...
The organism has sensors. I mean,
it's got the sense, but those sensors are in sense modeling, right? They're not just, in other words, it's going toward the sense. You could even say the physical system is constituting a model, if you like.
Yeah,
so,
instantiated.
So what it's doing is, it's like if it's the right kind of substance, then a glucose gradient. Some organisms just aren't going to have that model.
Yeah, right.
But this organism has that model, and so it's got it goes up a glucose gradient and avoids something noxious, right? So what that means is that there's of course an interpretation. We're sense making, right?
Yes, it's sense making. Yeah.
And part of what that is, of course, is detecting anomalies in the environment. It's like surprise. Okay. So here's one question I have is, I don't really get why syntactic information is not semantic, because you had to have a model to have surprise.
No, I don't think so. I don't, it's fluctuations. You don't need a model to have, a string of...
But a fluctuation is from the standpoint of a model. It's not just given with the world.
No, it's not a model. I would disagree, because there's an average and there's something that's above the average. That's model independent. I mean, if I just have a detector...
An average is a model.
From a physical, I'm not sure. I'm not sure I would agree with that. That it's a, I mean,
Okay.
well, of course, I have to use words to describe it. So right then, I've already have yes, it's a model. I mean, in the sense.
No, I mean, the very concept of an average is a model.
Yes, absolutely. I mean, but again,
Do averages exist in the world independent of the models? Dun, dun, dun. You don't have to answer that, Richie. Go ahead.
No. Because nothing, again, my whole point is that sorry, I just have to, the whole point here is that the world by itself, I can't say anything about the world. You're asking me, what is the world like by itself?
Exactly.
The whole point is that's what I'm trying to point out is that, that there might be here is a way to have the same kind of acuity, the same kind of precision that we bring to these questions of general relativity to questions about agency and environments and their co-arising. So of course, by itself, it's the Wittgenstein thing. I can't say it. There's no words, right? So, but if you're asking, if you want to bring me into the context of like, oh, now you want to describe things, then yeah, averages are real, and averages are model independent.
So let me take this in a slightly different direction, if I can. So I love your aspiration to bring physics to life. One of the qualities of life that is especially important in the Buddhist world, but also more generally, is sentience. At one point, at least I may have misheard this, and please correct me if I did, but you seem to have slipped in that robots could be agents in the way you're describing, and they would have the same properties that you are ascribing to, say, a squirrel. And if that's true, where is life?
That's a great question. The only reason I said that was I'm not going, just like I'm going to look at one of the interesting things about the hurricane and the cell is like hurricanes are these systems that have many, like you want to know, one of the things I hope would come out of this is you'd understand a little bit more about that transition, right? There was a time when the earth did not have life on it, right? But it was, like from the work of Sarah Walker and others, it was prebiotic. It was preparing itself in some sense for life. So what I hope might emerge out of this is a better understanding of why the hurricane is not an agent. We shouldn't consider it an agent, but the cell we do consider an agent. And the same thing may happen, like there's no robot now that you would really want to consider to be an agent in this way we're describing. But I'm not going to say that in the future, that there isn't the possibility that, that some kind of artificial system might exhibit proto qualities or might be on that boundary. One of the things we want to know here is, what does that boundary look like?
So then what is the relation between sentience and life?
Well, if you're saying sentience so define sentience for me, I mean, just so I know.
The experience of pain is an exemplar of sentience.
Yeah, the interior, that there's an interior world. I have no idea. Right, not yet. I mean, that's and again, I think there's aspects of this that I may not expect to come out of this, right? That may be beyond what I can do with math, right? But I may be able to capture other essential qualities of that. So I'm not even going to come close to saying, oh, this is going to get answered by that,
Okay, thank you. Thank you for your humility.
Well, are there any agents out there who want to ask a question?
I just wanted to clarify about semantic information and sentience. Just, are you saying that, is it that anything that exhibits sentience is using semantic information? Are those two things?
I think that I would say that's true. Anything that is absolutely, but where the boundaries, I mean, to me, I think cells are sentient. I think cells, but that's just my, cells, there's, I think, really interesting work on intelligence and at all levels of the biosphere. So I'm not willing to say that microbes, this is why I love Lynn Margulis, that microbes aren't sentient.
Or forests, maybe.
Or forests, yeah, the wood wide web, right? And
so then what about very complicated machines, AI and so forth? Do they not exhibit semantic information processing?
Not now. There's really, I would say not even close at this point, And so, what may be really interesting is that as we're just starting down this road.
Yeah,
and maybe, sorry, go ahead.
Like a robot does squirrel-like things and gets information from its environment. And if you scramble that, it'll screw it up, just like the squirrel.
But there'll be other aspects, like the robot, again, there's the relationship, the nature of viability with the robot is totally different, right? Because I can turn the robot off and I can turn it back on. Viability for an agent, what I would define an agent, is a one-way street.
But if you set the conditions for the robot to survive only if it, achieves its goals, and then you can mess with the goals. It just seems like you could make the experiment such that the robot would be the same in that example.
And I think we will do those experiments to understand, as we're trying to flesh out how semantic information relates to agency and environment. We'll do those. But I think ultimately, at this point, robots don't have the qualities that it would make it the kind of agents we're interested in. But that's all open. I think that's what makes this field interesting.
I wonder if there are any questions online. Al, do we have anyone who's got a question come up or something in the chat?
Thanks, John. There have been several, and they go in multiple different directions. So I've been looking at that. It's difficult for me to pull out something that I think maybe if I'd abstract something from them. These have come up a few times. It's so how does this correlate with some of what we've been talking about in the meeting, having to do with indigenous ways of knowing? Are there correspondences that you would point to? That would be one, and then also
I
Amy.
think also,
had something.
Al, I think the question that Amy posed relates very much to the question that you're asking. There's where there is sentience, there is autonomy.
Yeah.
And I'd like to just pull that perspective in, which is showing up in various ways in the chat.
Let me just address that question first about agency and autonomy, because Noah, this goes to your question, right? Agency and autonomy kind of always go together, right? And that's the difference with the robot. The robot's not really autonomous, right? The robot it's not autopoietic, right? It's not self-creating and self-maintaining. The robot is programmed by somebody else, right? And so the robot does, and so the autonomy is the same question, like trying to develop a physics perspective on this, about how both agency and its autonomy emerges. That's to me what's exciting about this. And so let me just, because I want to also address for the indigenous perspective, I don't know. I think that's going to be the really interesting things about the conversations that are started. What I see with the contemplative or the Buddhist practices, I see philosophical ideas that may be useful to underpin to draw from as metaphors as in this work. And I think with because indigenous cultures had such, their sciences were so closely tied to these critical aspects of living systems, that there may be, again, philosophical ideas that work as metaphors.
So, and I just want to, clarify especially really all the way back in early Buddhism, the idea that there's a perceiver, there's an experiencer, there's a knower, there's a doer. That's all an illusion, even conventionally. Like, in other words, that's not a good model of how we're operating with the world. Or even that's sort of part of what that does is it sets up this dichotomy.
Right.
So, in some ways, that doesn't mean you have to just throw that model out necessarily. The Buddhists don't have to be right about it, but does introduce a certain kind of caution, which is, where we find agency and autonomy might depend on where we draw the line.
Right.
Like, is it the cell and I'm just I'm not an autonomous agent, but all my cells are? Or is it like, my brain or a few parts of my brain, or, like the pineal gland? Or the PCC,
right, living there, right.
And like, where am I? So when you start to think of if I am the agent, like, what does that even mean? Like, where do I begin?
But that's what I see. That's why I think is exciting about this, because ultimately the agent and the environment are illusions, right?
Okay, then if that's what you're really trying to say.
That's what I'm trying to say, is that they're not.
Well, why didn't you just say that?
I did. I took 40 minutes and I said it.
We've
See, he was playing video games. He was on his thing like, pew, 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 while he was in the back.
Thank you so much.
Back room.
I'm not sure I got
in the
that
back-
story
yeah, the
out of
back
what you were
row.
saying.
Well, I think on that note, since we finally have done what we always want to do here, which is to enter into the differences and then find the unification temporarily, at least.
Right, and then go back.
So here we are. You know, I want us to be realistic in relation to time. I loved the interaction between the two of you, big brain primates, excuse me. And thanks, Wendy, for dropping that one on me. And also to know that this exploration will continue, not only between these two agents, and who are making environments for each other, but also, you know, this is what is really important for us to look into, how context or environment actually is entangled with us as so-called agents, and can you separate agents and environments? And obviously from the inactive perspective, you can't. So where does free will and autonomy play in this? But I'm not going to go further. As a merciful conclusion to an extraordinary exchange between our beloveds. And so we will conclude this session with the energy bristling in the air. Thank you. And we will come back to be together at 2:00 after a lunch at 12:30, as you know, where Andreas will be going further into the inactive perspective. And then all of us crazies will be up front with you crazies online and in the room for the final session, QA and exchange. And thank you. And I'm going to ask those of you who are in the chaplaincy training just to gather around me for a second, just for a brief communication before you go to lunch. The rest of you will repair to lunch at our usual meal offering. We don't do, and then I have a meeting with you right after that. And I look forward to seeing all of us together again at 2. Thank you.
Super fun.